Hi, welcome to Such and Study Tech. Today topic is omega notation. So when you can use the omega notation, now you can see asymptotic greater than, that is the faster growth rate. Here it represent lower bound of algorithm runtime, and by using big omega notation we can calculate the minimum amount of time. You can say that it is the best case time complexity. So this is the definition given to functions f of n and g of n. We say that f of n is omega of g of n if there exists constant c greater than 0 and n not greater than or equal to 1, such that f of n greater than or equal to c into g of n for all n greater than or equal to n naught. F of n, this is the one function f of n 3n plus 2 and g of n is n. Now we can prove that f of n greater than or equal to c into g of n. F of n value is 3n plus 2 greater than or equal to c into g of n, that is g of n value is n. Now we can choose any value for c. In big O notation you can take more than this, that is 4 or 5, but here in omega notation you can choose the less than that value. So I am consider c value is 1 and n value is 1. Now 3 1 plus 2, that is 5 greater than or equal to c value is 1 1 into 1, that is 1. So it is satisfied. Now we can check the n value is 2. In this case also 3 into 2, that is 6 plus 2 8. 8 greater than or equal to 1 into 2 2, it is also satisfied. So here you can say that f of n is omega of g of n. So g of n is the lower bound, f of n is the upper bound. So here in this graph also you can see f of n is the upper bound, c into g of n is the lower bound. Here x-axis indicates the size of input and here the y-axis indicates the time t. Now you can see n naught is equal to 1, then you can take n greater than or equal to n naught. Now for all n greater than or equal to 1, this condition is satisfied. That's why we can say that f of n is equal to omega of g of n. Thank you for watching.